Hello everyone and welcome back to exercise number 49 of the SolidWorks basic tutorial series. In this video, we're going to be designing a ribbed conical flange. Now, as always, in designing this part within SolidWorks, we're going to be using many of the SolidWorks features, namely the extrude boss base feature, the extrude cut feature. Also, of course, these features are pretty standard if you want to create any part within SolidWorks. But also in creating the ribs here, we're going to be using the rib tool for the first time. Also, if we want to create the other 11 copies, because we have 12 ribs in total, we're going to have to use the circular sketch pattern tool. Here we see the schematic drawing for exercise number 49. All dimensions are in millimeters. If we zoom in here, we can see that the unit system is set to millimeters, grams, and seconds. So that is the unit convention that we're going to be following. We have the isometric view, the diametric view. These are two pictorial views showcasing the physical features of the components. We have the front view and the section view. This section view is taken along this vertical line. So this is section AA. We have the bottom view and the top view. Now I realize the top view should be above the front view. Again, this is according to the conventions of engineering drawing. However, since we don't have any space here at the top, I decided to put the top view alongside the bottom view. And I've added these notes here at the bottom that says bottom view and top view so that viewers don't get confused. Anyway, so if we look at the component, we can see that we have a number of features. And in modeling this part, we're going to follow a feature-driven approach. So I think to begin, if we want to create a strategy in modeling this within SolidWorks, the first step is to utilize the fact that there is symmetry for the component. Of course, radial symmetry, because again, if you look at the component in its entirety, we see that we have radial symmetry. So the y-axis here serves as the line of symmetry. And to create the main body of the component, what we could do is sketch out half of the front view, okay? And after we've sketched out the half of the front view, we're going to apply the dimensions using the Smart Dimension tool. And then we're going to use the Revolve Boss Base tool to create the main body of the component, okay? This conical section, this mid-cylinder, as well as the bottom flange here. After that, we're going to look at the bottom view. And the bottom view here, we see that we have a cylinder, all right? You can see the thickness here, a cylinder of 5 millimeters. But we have a number of slots that run along these lines here. So we're going to have to do a lot of sketching here. Of course, we're going to have to create a center line and then use the offset tool to create the overall thickness here. We see that the thickness of the slot is 8 millimeters. And then we're going to use the circular pattern tool to create the copies, and then use the power trim tool to delete any extra entities. Finally, we're going to be using the extrude boss base tool to create the 3D aspect of this bottom feature right here. Also, if we look at the section view, we see that we have an opening that runs along the center of the component. Very much like how we created the main body of the component using the Revolve Boss Base tool. For this opening here, we're going to use the Revolve Cut tool and utilize the symmetry for the components. So we're going to sketch out half of this opening here, this cavity, and then we're going to use the Revolve Cut tool to create the opening in its entirety. After that, we're going to work on creating the ribs. So for that, we're going to sketch out the 2D sketch and then use the rib feature tool. It's actually a pretty straightforward process. To create the rest of the copies, we're going to use the circular pattern tool. And of course, we have a number of Counterbore features, these mounting holes for the bottom flange. So if we look at the top view, we see that we have 12 Counterbore holes in total. And these Counterbores are actually situated using a pitch circle with a diameter of 124 millimeters. All right, so finally, we're going to have to create this opening here, this inclined opening. So for that, we're going to have to create a new drawing plane that is inclined relative to the right plane or front plane. It's your choice. And then draw a circle, and then we're going to use the extrude cut tool to create the opening. For the rest of the copies, we're going to use the circular pattern tool. So it's a pretty simple problem in SolidWorks, but it's very fun to model it. Okay, so with that aside, let's get started with exercise number 49. All right, so let's start by creating a new SolidWorks part. Let's set the background to plain white, and let's copy exercise number 49 into SolidWorks. Let's go ahead and drag this upwards, make it smaller. Okay, so as I said previously, the first step is to create the main body for the component. And for that, we're going to have to create a 2D sketch for half of the front view and then use the Revolve Boss Face tool. So to start, go ahead and select Front Plane, Sketch, activate the Line tool, and starting from the origin here at the bottom, draw a vertical line all the way to the top. And then go horizontally, and then we're going to complete the process of sketching out half of the 2D profile. This represents the flange, and that closes off the 2D sketch. Okay. Now let's drag this here, and looking at the front plane here, you see that we have a number of dimensions. Let's first of all activate the Smart Dimension tool, and we can see that the thickness of the flange is 15 millimeters. So the thickness or length of this edge should be 15 millimeters. All right. The overall height, or the height from the cylinder right here, the mid-cylinder, should be 70 millimeters. So the length of this edge should be 70 millimeters. And we have the length or distance from this edge all the way to this point here should be 40 millimeters. All right. The diameter of the cylinder, half of it should be 45, since we see here that we have a diameter of 90. So go ahead and set the distance between this edge and this edge as 45. All right. And the diameter of the flange, the bottom flange here, overall it's 150. So the length of this edge should be 150 divided by 2, which is 75 millimeters. All right. And what else? There's this angle here. If we look closely for this conical section, the angle, this inclined edge, should be 60 degrees relative to the horizontal. So what we're going to do is very simply, let's drag this to the side here, activate the center line tool, and let's draw a center line, a horizontal center line starting from this point. Activate the Smart Dimension tool, and the angle between this edge and this horizontal center line should be 60 degrees. All right. Now the sketch is fully defined. All entities are black, and we have a note here at the bottom that says that the sketch is fully defined. So what we need to do now is press the S key, select Revolve Boss Base, delete this axis of revolution. By default, it selected the last entity that I created, and click on this vertical edge here. All right. And then click OK. Now that creates the main body for the component. What we need to do now is work on creating the bottom feature right here, this bottom feature with the slots. So what we need to do is very simply select this bottom face, sketch, activate the circle tool, and from the origin right here, draw a circle. Activate the Smart Dimension tool, and if we look closely, we see that the diameter of this bottom cylinder section should be 145 millimeters. So this needs to be 145. Sorry, undo. 145. Okay. Now what we need to do is create a second circle. This second circle represents the opening here within the bottom section. And if we look closely, we see that this cylinder right here, or this circle, should have a diameter of 75 millimeters. So activate the circle tool, and starting from the origin again, draw a circle. Smart Dimension, and this needs to be 75 millimeters. Activate the Line tool, and starting from this point here at the top of the circle, all the way to the bottom, draw a vertical line. Now go to Offset Entities, and if we look closely, we see that the slot opening here at the bottom should have an overall distance of 8 millimeters. So go ahead and select Bidirectional, all right, and set the distance as, the offset distance as 4 millimeters. What that will do is basically offset this middle line right here in both directions, to the right and to the left. So it will offset this line to the right by a distance of 4 millimeters and to the left by a distance of 4. Overall, we'll have a offset distance of 8. So go ahead and select this line right here and then click OK. Now go ahead and select Extend Entities, and if we look closely here, if we zoom in, you see the lines aren't touching the circle that we created. So click on this line and this line. All right, activate the Trim tool and go ahead and delete any extra entities here at the top. and this middle line section right here. All right, so how many slots do we have? We have 4, 5, and 6. We have 6 slot openings in total. So what we need to do is go to linear sketch pattern and then select circular sketch pattern. Now for the entities to pattern, go ahead and select these two lines right here, 1 and 2. Set the number of instances to 6. All right, and then click OK. Now just use the trim tool and delete any extra entities that you don't need right here, leaving behind the 2D sketch for the feature at the bottom of the component. Okay, so now press the S key, extrude boss base, and we're going to set the extrusion thickness, if we look at the front view, as 5 millimeters. So go ahead and enter a thickness of 5, and then click OK. All right, so now we completed the bottom section of the component. What we need to do is now work on creating the rib. So what we need to do is select the front plane, sketch, zoom in closely, activate the line tool, and what we're going to do is we're going to very simply sketch out this portion right here of the rib, this top portion, leaving out the bottom edges, the side edge and the bottom edge for the rib, right? So what we're going to do is from this point right here, draw a line, activate the 3-point arc tool. So starting from this point all the way to this point right here, line again, and then close off all the way to the bottom right here. All right, now activate the Smart Dimension tool, and if we look closely at the section view, we see that we have certain dimensions for the rib, namely we have the length of this top edge and this bottom edge right here for the rib as 3 millimeters each. So the length of this edge is 3 millimeters. The length of this bottom edge is 3 millimeters as well. We can see that if we look at the section view, that from one end of the rib to the next, we have an overall distance of 140 millimeters. So starting from the origin here all the way to this edge, half of it should be 70 millimeters, right? And an overall height for this rib, if we look closely, is 30 millimeters. So starting from this edge all the way to the bottom right here should be 30 millimeters. Finally, the radius of curvature for this region right here is 15 millimeters. Again, this is according to the image here. You see that the radius of this curve is 50 millimeters. All right, so now the sketch is fully defined. All entities are black in color, and we have a note here that says fully defined. So we're ready for the rib feature. So go to Features, select Rib, and what we're going to do first is create the thickness of the rib. So if we look closely at the top view, we see that the rib has a thickness of 3 millimeters. So go ahead and assign a thickness of 3 millimeters. All right. And here's going to ask us for the direction. Where exactly would you like to create the ribs? Ending at what region? This side or the other side right here? Of course, we're going to have to create the rib that extends all the way to the body. So go ahead and select this option and then click OK. And that creates one of the ribs. But of course, we have 12 ribs in total. And we have to create the other copies. So what we need to do is we're going to have to use the circular pattern tool. So go to linear pattern and then select circular pattern. Here's going to ask us for the direction. So go ahead and select any circular edge. And for the number of copies, set it to 12. And then click OK. And that creates the rib section for the component. All right, so now let's work on creating the counterbore features, because if you look here, we have mounting holes represented by counterbores, right? So let's go ahead and select this top face, sketch, activate the circle tool, and starting from the origin, we're going to draw a circle. Click this entity, and then press Q to convert this to a construction geometry. Activate the Smart Dimension tool, and of course this centerline, or this centerline circle is actually a pitch circle that will help us determine the position of the counterbore holes, right? So you see here from the bottom view that these holes are situated on a pitch circle with a diameter of 124 millimeters. So the diameter of this edge needs to be 124 millimeters. All right, so now activate the centerline tool, and starting from the origin, create a horizontal center line. Likewise, from the origin again, create an inclined line all the way to this point. What we need to do is assign the angle. If we look closely here, we see that relative to the horizontal, the position for one of these holes should be 15 degrees relative to the horizontal, right? So set the angle between this edge and this horizontal edge as 15 degrees. Activate the circle tool. So now, of course, we can very easily position the counterbore holes because we've converted, or basically we have the polar coordinates. We have the radius and we have the angle, right? So now starting from this point, draw a circle, activate the Smart Dimension tool. And if we look closely here, we see that we have 12 holes, 12 counterbore holes. And the diameter of the larger hole is 12.24 millimeters with a cut depth of 3.65. So this needs to be 12.24. Press the S key, extrude cut. And again, this is 3.65, so this should be 3.65. All right, and then click OK. Are we done yet? No, there's actually a smaller hole for the counterbore features. So go ahead and select this space, sketch, activate the circle tool. From this point right here, the center of the circle, draw another smaller circle, activate the Smart Dimension tool. And we see that the diameter of the smaller hole is 5.5 millimeters, and it says here that it's through, meaning that the hole goes all the way through the component. So this needs to be 5.5. Press the S key, extrude cut. Set the end condition as up to next, and then click OK. Now we have a counterbore hole that goes all the way through the component. But of course, we have 12 copies, and we just created one. So to create the other copies, the other 11 copies, I'm going to use the circular pattern tool. Direction of the pattern, select any circular edge. And for the features to use, we're going to select the last two cuts that we just did, this cut and this cut. All right, and then click OK. And that creates the mounting holes for the component, the counterbore features. All right, so now we just have, a few things we need to do. Mainly, we have this opening that runs along the center of the component. So like I said previously, we're going to select the front plane, sketch, using the line tool, and starting from the top here all the way to the origin, we're going to draw a vertical line. All right, activate the line tool again, and we're going to sketch out half of the opening right here, all the way to the bottom. Okay, just 1 second, just undo that. Line tool. And then close it off. Okay. So now activate the Smart Dimension tool. If we look closely at the dimensions, we see that the overall diameter of the smaller hole is 30 millimeters. So the distance between this edge and this edge needs to be 15 millimeters. All right. The distance between this edge and this bottom edge should be 32 millimeters. And the distance between this vertical edge and this edge should be 62 divided by 2, which is 31. All right. Is there anything else? The sketch now is fully defined. There's nothing else we can define. So now we're going to have to create the fillet for the component. So select fillet, because this edge right here has a fillet radius. And we're going to set the fillet radius as 15 millimeters. Select this edge, and then click OK. All right. Now press the S key. We don't have the Revolve Cut tool. We can change that later on. Go to Features, Revolve Cut. For the axis of revolution, select this vertical edge, and then click OK. All right, so that creates the opening for the component that runs along the center line. Okay, so now we just have one more thing to need to do. We need to create this inclined hole on this inclined surface right here, this conical surface. So go ahead and select front plane, sketch, activate the centerline tool, and from the top, this midpoint right here, all the way to the origin, draw a vertical line. Activate the centerline tool again, and again, if we look closely, we have a angle between this line and the top edge should be 30 degrees. However, it hasn't specified where exactly the hole should be relative to this curved surface here. Since it's not provided, automatically you should know that it lies at the midpoint of this inclined edge. So just to give you an idea, just hover over this edge right here and activate the midpoint, and then go all the way to the point right here. Activate the Smart Dimension tool and set the angle between this inclined edge and this top edge as 30 degrees. All right, so now the sketch is fully defined. What we need to do is exit the sketch, go to Features, Reference Geometry, and then select Plane. We're going to create a new drawing plane, all right? So the first reference that we're going to select is this inclined line. The second reference is this point right here. And that will create a plane that is tangent to the conical section right here, this conical curve section. And then click OK. Right-click on the new drawing plane, select Sketch, Normal Tool, activate the Circle tool, and starting from this point right here, draw a circle. Activate the Smart Dimension tool, and if we look closely, we see that the diameter of the hole should be 12 millimeters. So this needs to be 12. All right, press the S key, extrude cut, set the end condition as up to surface, so right-click on your mouse and then select up to surface. Which surface? This curved surface on the inside. All right, and then click OK. Now we don't need this drawing plane anymore, so go ahead and right-click on the drawing plane and then select Hide. Similarly, we have this sketch here. We don't need it right now, so right-click here, Hide. All right, so that creates one of the holes. We need to create the other 3 copies. So as always, we're going to use the circular pattern tool. For the direction, select any circular edge. For the features, go ahead and select the last feature you just created, which is the extrude cut. Set the number of copies to 4 because we have 4 in total. And then click OK. And that completes the modeling process. Of course, we need to assign a material. We're going to use the material of alloy steel. So delete this image. Right-click on material, edit material. Scroll down, select alloy steel, apply, close. Now for the moment of truth, go to the Evaluate tab, select Mass Properties, and the final answer that we should have here, or what you have, is 5,766 grams. The final answer is 5,766 grams. All right, so that concludes exercise number 49. I hope you all enjoy this video. If you find this content useful, please don't forget to like and subscribe. I'll see you all in exercise number 50. Until we meet again, bye-bye.